First, two blocks with mass m1 and m2 are connected by a light string on frictionless horizontal surface. A horizontal force F is applied to one of the blocks, causing the system to accelerate forward with a constant acceleration. Find the tension in a string between the two blocks. So for this question, I will teach you a method called hold, then separate method. Basically, what this method is about is first, find the value that you need by analyzing the entire system. For example, in this question, it's a two-block system. After you find the value, you can plug that value back to one of the object or analyze only one object and then got the correct answer. If you think this method is a little bit, hard to understand literally, after I show you this question, after I explain you this question, you will feel like, oh my god, this is so easy. So let's begin. First, there's an F over here, right? Causing the entire system to move forward with constant acceleration. So first, let's write a net force equation. F is equal to, since we treat the system as an entire object, like a very big object, so there's no internal forces between them. So let's see what forces is act on the entire system or this big object. Only F, right? Also, there's no friction, so we don't need to write friction over here. So it's only F. It's equal to ma. What is the mass of this big object? It's easy, right? It's just a sum of the two objects. So sum of the mass of the two objects is equal to m1 plus m2 times a. And then we can get the acceleration for the entire system, which is equal to F over m1 plus m2. After we find the acceleration, after we analyze the entire system, the next step is to plug in to the separate part. So the entire system is moving forward with the acceleration F over m1 plus m2, right? Which means each of the single object are also moving forward, accelerating with this much of acceleration. So let's analyze m2. No, wait. Actually, let's analyze m1 because it's easier. So let's write a net force equation for m1. Net force m1 is equal to, what force is act on this single object m1? Ft, right? It's equal to Ft. And it's equal to m1 times a because we're analyzing the single object over here. So then you can find Ft just by plug a to the acceleration over here. So now let's find Ft. Ft is equal to m1 times F over m1 plus m2. So this is your answer. This method is actually very helpful when it is asking you the internal force or asking you the internal force in the question. So keep in mind.